What is data science? What is data science? I don't know how many of you attended Power BI, right? So using Power BI tool, or it's a data visualization tool. It is also called as a data. Sorry, it is Power BI is also a data visualization tool, and it is a self-service business intelligence tool, and even Tableau and ClickSense, the ClickView, right? These are the tools are helpful to create a reports and dashboard. With those reports and dashboards, we can get to know what is happening currently in my company, what has happened in the past. But in the case of advanced tools like Power BI and even in the Tableau and all, right, you can do some kind of forecasting. Okay, you can do some kind of forecasting. But if somebody asks you to quantify with the given factors how much I can expect the sales in the future, right? You cannot tell that. So what we have seen was kind of a descriptive statistics, okay, descriptive statistics and diagnostic, descriptive analytics, and we have two or three types of analytics. One is as part of analytics, we have something called descriptive analytics. As part of descriptive analytics, we take the snapshot of we show the snapshot of what is happening currently and what has happened in the past. Okay, so that we will get to know, okay, where we need to improve. So currently we are doing very well in all the region except the south region, and for a specific category. So why are we not doing it well? That is the next step. First thing is, when you look at the report or report, you get to know that in the south region, a specific category, we are not doing well. As soon as you notice that, you wanted to come up with or you want to take a deep dive. So why are we not doing well in that south region for a specific category? What is my current revenue compared to previous month or previous quarter? What is current quarter revenue, previous quarter revenue, and what is my current quarter margin and previous quarter margin, net margin? My current quarter revenue and the previous quarter revenue is more or less same, but my current quarter net margin is less, almost 10 to 12% lesser than my previous quarter's net margin. Now we can see that one. So the report can show this. And again, with the interactive report, we can change the region, we can change whatever, we can apply different filters, and by applying the different filters, you can get different insights. This is one of the insights you got it. Like the previous quarter and current quarter, the sale is, the revenue is same, but you can see a 12% dip in net margin in this quarter. Why is that? Next question is why. So you have drill down functionality. You can drill down or drill through. With the drill through, you can navigate to another page of the report and see, in which region, in the specific, let's say in the south region, why the sales is less. You can find out, right? So why not the sales. I'm talking about the revenue and margin. Both of them are same, but still, why am I not doing good? Okay, and when you do a deep dive, you get to know that the the shipping cost was more, or recently they increased the GST and other thing, or maybe we have invested more on the advertisement expenses. In this quarter, we expended more on the advertisement. So in that kind of situation, right, you are okay, so we spent more money on the advertisement, since our expenses are more compared to previous quarter. Fine, again we need to take a look at the expenses in your dashboard. So when you look at the combination of all things, you will get convinced, okay, this month we have spent more money on the advertisement. Maybe we can see the returns, ROI, in the upcoming months. Okay, so you can do that. But what if somebody is asking you, so how much money customers can spend in the upcoming quarter, or so which products we can stock up in the next quarters, so that more number of customers should come and buy it from us. And if you overstock, also problem. If you understock, also problem. If you overstock, what will happen is your money will get locked in your warehouse. If you understock, what will happen is customers will get customers get this will have some kind of frustration, right? They come and check out the products in your website. If they don't find it, every time when they come to your site, and if they say the out of stock, they will lose trust on your site, and immediately they will walk out of your e-commerce website and they will go and order it somewhere else. Okay, so but is there any way I can predict or forecast how much items or units we can sell across all the categories, across the stores? That is another challenge. When you work with a large retail chain like Walmart or Target or anything, right? They have close to 2000 plus retail chains spread across the globe, and each chain they wanted to come up with the forecast. That's a different thing altogether. But first of all, is it possible for me to predict which products we sell more, which products we sell moderately, which product we sell less in the upcoming quarter? Is it possible to predict it? That is what the management question. So far you have seen enough reports. We have a lot of reports, profit and loss report, general ledger, also you shared it with me, and you have assets and liabilities, balance sheet, everything I have seen. We have almost we are close to having 300 to 400 reports are there. All these reports are related to my descriptive analytics. Maybe there are some reports you have given me the highlights or annotation saying that this is the root cause for decrease in the margin. This is our cost of goods sold, right? The cost price was more, and or maybe because of offer we have given more offers, our margin was wafer thin during this offer time, hence the margin is not so up to the mark. Okay, we sold more, but we sold it at the wafer thin margin. So it doesn't mean if I sell, if my revenues, if my sales is, let's say 10 lakhs or 1 million, that doesn't mean my profitability is going to be 0.5 million, right? Depends on the item what you sell, and depends on the offer what you give to who the customers to come and buy more and more from your website, right? So that is what. So sometimes, right, in Flipkart, what they do is their onboarding cost is very less, and even they sell it at the negative margin for few items. Okay, because they want to onboard more and more customers. The onboarding cost is very high. So these are the different strategies. Different reasons behind the decrease in or dip in the profitability. Okay, my revenue is very good, it's compelling, but still margin is not up to the mark. There could be a number of reasons. Okay, using diagnostic analytics, by digging detail into the data, you will get to know. But I do everything I can do it. But is that possible for me to predict what is going to happen in the next quarter? How much is it possible to predict how much a customer can spend in the next quarter? How much a customer can spend? Is it possible to predict it? If you have a mechanism to predict well in advance about the customer spend across various segments, right? It is well and good. That is where the predictive analytics came into picture. Now the question is, are there any difference between the predictive analytics and data science? In the case of predictive analytics, what we do is we predict the future. We predict the future like an astrologer. And then we come up with some kind of remedial action, right? So that's what we do it when we go and meet some astrologer. They say these are the things are going to be bad in your astrology, and right, so you need to go and do this. Similarly, here also we do prediction to mitigate the risk. Sometimes we wanted to, sometimes by predicting, by conducting the predictive analytics, we can preempt the risk. the risk illama பண்ணிடலாம், right? Preempt the risk, or we can mitigate the risk. Though the risk will be there everywhere, risk will be there. Is there any way I can mitigate the risk or preempt the risk? Not all the time you can preempt the risk. Some extent you can mitigate the risk, right? So with the help of predictive analytics we can do that. Now the question is what these terms are. If you talk to any data scientist, artificial intelligence guy, right? So they use all these lingos where they talk about artificial intelligence. Some people they say predictive analytics, data analytics, business analytics, data science, machine learning. All these different terms they use it. Or these terms are different. Now let us take a look at this. And what is artificial intelligence? Before I discuss about the data science, what is data science, right? We just took a digression and we discussed about the types of analytics, like the descriptive analytics and diagnostic analytics. As for diagnostic analytics, we find out why it happened, right? So we find out the root cause or the cause behind some red flag, right? So these are the reason why. Fine, those are the types of analytics. Next, instead of looking at the current and past, if I want to do a prediction, that is where the predictive analytics coming into picture. Fine. Now what is this term artificial intelligence all about, right? So in the past, the scientists, what they thought, is there any way we can give the brain to the system, human brain to the system, so that the system itself can think like a human and then it can make the decision on its own instead of relying on the human to feed or take decisions. Is there any way we can give the brain to the system so that the system itself can make the decision like how a human can take? The classic example is self-driving car. Self-driving car, Google, right? So they are the pioneer or the trendsetter when it comes to artificial intelligence. They are the one introduced the self-driving car. Okay, and in the self-driving car, you don't have to have a driver. All you need to do is just hop into the car and you tell the car where it should take you. That's it. And then you can close the door and you can sleep it. That's all, right? It will take you to the destination. Once you reach your destination, you will stop the car and you need to get down. That's all. And then if you tell the car, it goes and pass on its own in the allotted parking lot. It's quite interesting, right? It's no longer a fiction. It's not a scientific fiction, right? So it became what was once called as a scientific fiction. Now it has been, it became a reality now. Okay, without driver, the car itself makes the decision. When it finds the red light in the traffic light, it stops automatically. When it finds the amber light, it prepares to stop the car. When it finds the green light, it starts moving it. The vehicle moves. And it knows where to turn, how to turn, how to maintain the lanes. In US, the lanes are very, very important. Okay, you have to drive your car inside the lane. Okay, it should not touch the lines. Everything is taken care of automatically. So in the case of the self-driving car, the brain is given to the car. Without human intervention, the car can take any decision. So for example, if any object or anything, for example, the livestock like a cattle or anything, when it crosses the road suddenly, right, or if it scampers the road, the car can make a decision on the fly without any human intervention, and then it knows how to divert the car, how to stop the car. If suddenly something crosses the road, right, it happens in our city and town, right? Suddenly someone put the right in the auto, right? You see that they put the right turn light and suddenly they turn it on the left side, right? So the car makes the decision on its own, even in case of any uncertainty happens, how to preempt or how to overcome that kind of things. It has that much of interest because the cars self-driving cars got trained with a lot of data. Anyhow, we will discuss about that later. Okay. So first of all, what is artificial? Artificial is based on the idea that machines can make the better decision on human itself. on humans' behalf. Okay, so we have given the brain to the system in simple term. Okay, so the artificial intelligence is an umbrella term for machines capable of making or learning and the perception, making the perception, logic, everything is possible with the help of the artificial. We have given the, instead of giving the human intelligence, we are giving the artificial intelligence to the system, which is exactly like, it mimics our human brain. That is what your artificial, it is an umbrella term. Okay, and the next one is, what is data analytics business? And this is basically we use the current data and past data, and then we analyze the data. Based on the data, we make some decisions, right? So whether we need to do some kind of course correction based on the insight what we see it in the charts, visuals. Fine. The business analytics, those guys, they are very much familiar with the domain knowledge. For example, if a person is a business analyst in stock market, equity, right? You'll be knowing in and out of the equity market and capital market. Okay, if a person says he's good in banking, business analyst, they are the one very good at the business domain. Data analysts, they are not so good in business analytics, right? They don't have much domain knowledge, but they are very good in how to extract the data, how to process the data, pre-process the data, how to clean the data, and how to generate reports and all. Okay, this is based on, this is domain based knowledge, and this is like a ETL BA, business intelligence knowledge, like ETL reporting, they do it. And and this is basically, right, current and past. And data science, I will discuss this. Okay, and next one is machine learning. Okay, the machine learning, and look here, so artificial is the umbrella term, and the machine learning falls under artificial. It's one of the branch of your artificial intelligence. And then the deep learning evolved from your machine learning. Then what is data science? Data science encompasses everything. It encompasses, if you say you are a data scientist, you should be knowing machine learning, you should be knowing deep learning also. It is not mandatory that you should be knowing deep learning also. But nowadays, yes, you should be good at everything. And the computer vision is also one of the, even this one also sub branch of your data science or artificial intelligence, right? The computer vision aims at giving computers a visual understanding of the world. Okay, so as the name says, a vision, right? So see, in the case of machine learning, what we do is we give the brain to the system. Classic example is the car, self-driving car. With the help of the machine learning algorithm, we give the brain to the system. System is, in this case, a car. Nowadays, I don't know how many of you heard about. See, the autopiloting is also there. Without pilot, the flight can fly. So everything is possible because of machine learning algorithms. With machine learning algorithm, you can give the brain. If I give the brain, is it sufficient for the car to drive? How many of you agree with this one? Or how many of you say with the brain you can do anything? Can I do everything with brain itself? So I have given now with machine learning algorithm, they have given the brain to the car. So is it enough for the car to start drive on its own? No, it needs a vision. It needs eyes. See, the whole idea of computer vision is to enable the computers to see, identify, and process, analyze the images. When it visualizes something, hey, something wrong is going to happen, or when it sees, when it approaches the traffic light or signal, it should know, right, whether the traffic light is green or amber or red. Only when the system has some eyes, it can understand, okay, this is a red light, this is the amber, and this is the stop light. And then as a human, what we do, right, with our eyes, we can make red light, we need to stop. Similarly, in the case of computer vision, right, so we enable the computers to see, identify, and process and analyze the images, image recognition, all the things are comes into picture here. object detection, and the image processing, everything comes into picture here. So when it see the image, when it see the traffic light in the form of image, it checks the color. Oh, it's a red color, so it analyzes. So in addition to brain, eyes also very much important. Without eyes, you are like a blind man. Even if a blind man has brain, but he has no vision. Okay, so see, using machine learning, we can give the brain to the system. Using computer, we can enable the systems or cars to see the world. And so how it can see the world? The cars are bombarded with a lot of camera, CCTV, all the things. So it takes the videos and images on the fly, and the systems can make decision with the images or the videos, whatever it can be, visualize it on the fly. Everything happens in a matter of seconds, nanoseconds. If there is a delay in processing it, if there is a delay in getting the image, what will happen? That's all, right? It can go and bang the vehicles that are driving along with them, or it can go and bang the vehicles which are running just before the car, right? Or before or after the car. So brain is required, the eyes are required. The computer vision enables the cars to visualize the world with the help of the sensors. Sensors enables these computers to understand the environment, and machine learning algorithms helps us to give the brain to the system. So what happened? Scientists, they made significant improvement for the traditional machine learning algorithm. Now what they did, they improvised the existing machine learning algorithm to make it more sophisticated and with higher accuracy of predicting all the things. Okay, that's where the deep learning comes into picture. It is evolved from machine learning in simple language. Okay, and we have something else called cognitive computing. IBM, they introduced something called cognitive computing. Anyhow, I'm not going to talk this at this moment. You will get overwhelmed if I talk about this. We'll discuss this later point in time. So now you understood, using machine learning, we can train the system with the historical data. Okay, if using machine learning algorithm, we can give the brain to the system. So do I have to buy a brain, artificial brain? Not a brain. As part of machine learning, a lot of algorithms are there. With that specific algorithm, what we do is we train the system with the historical data. With the historical data, system will learn it. The system will learn it. Don't worry about this. We'll explain it. Okay, all the things. And the deep learning is advanced. You just think it is an advanced version of machine learning. And computer vision, with this, we can enable the systems to recognize the images, and or we can do video analytics, everything as part of this, right? So all these things falls under artificial intelligence. Machine learning, deep learning, computer, all these things falls under artificial intelligence. Data science encompasses everything. Okay, if you say data scientist, you are working in the artificial intelligence, which encompasses all these three. And so what is predictive analytics and the machine learning, deep learning, all things? See, in the past, we were using the term called predictive analytics. That's all. Even in the predictive analytics, we train the system, and then we, with the help of the algorithms, to learn the patterns. Basically, we are using the machine learning algorithm to learn the pattern from the historical data. With that learned pattern, the system can apply for any new environment or even any new incoming data, right? So that's how it works. And the predictive analytics is also similar to your machine learning algorithm, but in the past we used to call predictive analytics. Okay, and this name got evolved as machine learning. That's all. Nowadays we have big data, and we have huge volume of data, and so, right, so training the machine learning algorithm on the huge value data. In simple term, this term got evolved as machine learning. Okay, nothing much difference. Hope you understood what is artificial is an umbrella term. The sub branch of artificial machine learning, deep learning, and computer vision. The data science encompasses everything. The predictive analytics, this term got this is basically renamed as machine learning. In the past, we used to call this predictive analytics. Data analytics, business analytics are two different branches. As part of machine learning, before we train the model, everything, we as a data scientist do the analytics. Okay, data analytics. We explore the data. Everything as a data scientist has to do. And now the question is, as a data scientist, do I need to know the business domain knowledge also? Yes, as a data scientist, you should be knowing the business also very well. If you know the business very well, domain, for example, you are into banking domain, you know the in and out of banking. Okay, so or if you are into finance, you know what is payables, what is receivables, all the things. If you know it, right, related to accounting thing, right, then you are very good with that. Okay, and but it is nowadays, right, we cannot say I am very good in banking, so hence I can become a data scientist in the domain, in the banking domain area only. It's not like that. Okay, so maybe we can say it is kind of agnostic. But if you are going to be a data scientist for any domain, try to be very good with that domain also. Learn the banking domain very well, and if you know the domain very well, as a data scientist, you should be able to build the compelling stories around the data. Storytelling is one of the important tasks, right, as for a data scientist. Okay, now let us first understand what exactly machine learning is all about. What is the difference between human learning and machine learning? First, let us understand. Supposing you want to learn a car, you want to learn how to drive a car, and what you do is you call you fix up an appointment with the driving school, and then the driver comes to your house every day, and he trains you. Okay, and he explains you everything, all the parts, how to drive a car, everything. Initially 1 week he drives the car. You simply watch him, how he drives, how he reacts to the different type of traffic, moderate traffic, hectic, heavy traffic, and low traffic. In all these type of traffic, how he reacts and how he applies the the gear, and when he raises the accelerator, when he applies the brake, right? So all the things you watch him 1 week, and after a week he will sit next to you, and you will have to sit in the driver's seat, and then he will ask you to drive initially in the low congested area, less congested area. He will ask you to drive it there, and if you make any mistake, initially you will tend to make a mistake, obviously. So he will correct you. Hey, you are not supposed to do this way. If you have to take a left turn, first you need to put the left turn light, and then only you need to slowly turn the car to the left side. You are not supposed to turn fast, because people may come on the left side of your vehicle also. If you turn it fast, you may go and hit them. So likewise, he teaches you everything. You make mistake and he teaches you everything, goes to your brain. You just think your brain is like your machine learning algorithm. You did a lot of mistake, and then how to avoid those mistakes, he trained you. Everything went into your mind. After 1 week, after 2 weeks, after 3 weeks, he'll put you on the moderately congested road, and finally he put you on the heavily congested road. Even so, in the heavily congested road, when you drive the car, whatever the lessons you learnt in the past, when you drove in the less congested road and moderately congested road, you apply everything in the heavy traffic road, right? So apply this. Hey, in that less congested road, this is what happened. In the moderately congested road, this is what has happened. Congested area, this is what happened. This is how I reacted to prevent the accident. Okay, the same thing will follow, but still a lot of many uncertainties can happen, because different people driving behavior is different, right? So you will learn many things after 1 month or after 1.5 months. You learned driving very well, and also you understood various patterns. Simple example is the person is putting the left turn light, but he is turning on the right side. This is one pattern you learn. This guy is putting the left turn light instead of turning the vehicle on the left side, but his head was facing on the right side. That means though he put the left and light, he is not going to turn. So his head is looking on the right side, which means obviously he is going to turn the vehicle on the right side. These patterns are right. Our people way of driving, you understood everything, and then what you do is you decide, okay, so when somebody is putting the turn light, you are going to slow down and simply you watch, where their head is turning, all the things, right? Vehicle is turning, right? So with that slow turning itself, you understand, okay, this guy is turning on the right side. Better we will slow down the vehicle till let him go away. Like this, you learned many patterns. This is one of the examples for the pattern. Maybe it's a not so great example. Okay, and you learned this pattern, and what you do is you apply this pattern. Whatever the lessons that you learned in the past, you apply it. See, another classic example is, this is the one, the loan thing. So this is the, let's say you are the manager. Okay, you are the manager in a bank, in a leading bank, and your branch manager, he walks up to you and he tells you, hey man, I don't know what you are going to do for the upcoming quarter. You need to increase the market share in the sense of the revenue by 35%. I don't know what you are going to do. Okay, this is the goal I am going to set you, because you are looking for salary hike and promotion. If you want that, you need to increase the revenue for the upcoming quarter by 35%. Okay, what you are doing is, okay, you are just thinking various strategies, but this one seems to be little bit unrealistic, but within a quarter you are expecting me to increase the revenue by 35%. Is it possible? And you are just thinking, and finally you come up with something like cross-selling strategy. What is cross-selling? Bank sells different products, right? They have something called fixed deposit, savings account, current account, checking account, like different types of accounts are there. And also they offer credit cards and they give loans also. And what you are thinking is, okay, for what is my current customer base? My customer base is currently, it is going to be 10 million customers. And let me see, is there any way we can target our existing customer base, right? The potential customers, we will try to find out the potential customers. Is there any way we can give our product, the loan, we can market our loan product? Okay, so in the case of loan, once you give the loan, no matter see here in the case of loan, as opposed to credit card, even if you make the payment well out of the schedule or well before the due date, you have to pay the interest for each month. EMI, you need to pay the interest along with the principal amount. Whereas in the case of credit card, if you pay the money well ahead of the due date, you don't have to pay the interest. So hence, as a manager, you think, okay, if I offer the loan, if I approve the loan to my existing customers, especially the potential customers, the chances are that I can increase my revenue. What is the way out? Is it possible for me to achieve that target? So what you are doing is you are taking randomly sample the data and you are just looking at it. So what you are seeing here is you have taken the data from the existing customers thing, and you are seeing that this customer ID is 1004, his years of credit is 9, and his income is this one. He is not owning a house, his loan balance is this one. Delinquent, last 2 times his account got, his account became delinquent. Maximum billing cycles late was 3, and is he a profitable customers? No. Basically, you wanted to find out which all customers are profitable customers, which means those are the potential customers you can trust and give the loan. Just because if I offer the loan to my customers, I'll get both the principal and interest amount. Blindly, I cannot close my eyes and approve the loans to all my customers, right? You need to find out which customers are really good, which customers has the repaying capacity. That is also a very important thing. So the credit score nowadays, with that they are going to determine it. For example, as a manager, you're just taking the data and you look at it. So this guy is owning the house. In the event of default, if he is not going to repay the money, what we can is owning the house, we can probably, right, we can catch hold of him, something like that, okay. And his loan balance nothing, he already paid all the loans, maybe he wouldn't have taken any loan, and only one time his account became delinquent. This is something nonsense, okay. Maybe it's a zero, and billing cycle is late is zero, and he's a profitable customer, his income is also good, and he's owning a house, okay. In the event of default, we can still recover the money by asking him to sell the house, something like that, okay. And this guy's salary is more compared to this guy, and he's also owning a house, but he's already having a loan, 1,000 rupees or something like that. But compared to his salary, though he is having a loan balance, still we can offer him a loan. It doesn't mean somebody is having a loan balance, we will not give the loan, right? Still we can go ahead and give the loan. So likewise, look here this person has no loan balance, and his income is good, and this person income is much better than this guy, but he's having a loan now. He took a loan, but his loan amount is not so significant, right? Very less. Still we can go ahead and give them. Likewise, different pattern. This is one pattern. These different patterns, right? So by looking at these three records, we are able to get three different patterns. When it comes to machine learning, just remember the term pattern. So machine learning algorithms learn the patterns from the data. So what we do is, I'm going to classify this data into two different two different things. One is the input features. All these columns, starting from customer ID to the forget about customer ID, or you just think that for the time being, starting from the customer ID to till maximum, till the this one I call this a input feature. I call the input features. Okay, and this one, these are my input features. I'm going to call this as my output feature, labeled output feature. So this label, we have labeled each customers. Let's say in this case we have labeled this customer as no, yes, yes. No means is a non-profitable customer, yes means is a potential customer. How we label this? Based on the pattern, based on the combination of various factors. One factor is income. Income is very good, and he's owning a house. His loan balance is less. This guy no loan balance. His salary is also reasonably good, and importantly, he's owning a house. He's owning vehicles. With this, we are going to determine, yes, this customer is. Let's say based on this is my historical data, based on the loans which he offered to the existing customer in the past, we recorded all this information. So this input feature, with the input feature along with the labeled features, label output features, we are going to train our machine learning algorithm. So for illustration purpose, I have used the decision tree algorithm here. Machine learning algorithm is one of the supervised machine learning algorithm which falls under machine learning. So train your supervised machine learning algorithm. You need to have both the input features and an output feature. What do you mean by feature? Features are nothing but the call. In the case of machine learning world, we call the columns as features. So this is also another column, we call it a feature, but it is a labeled output feature. This kind of a question, this kind of answer. Okay, and what we are like, how we teach a kid. Let's your father is lending money to various people in a city. Now he is growing old, and he wants to teach you, whom to lend. How will he teach you? He will tell you, hey, my son, if a person is owning a house and vehicle, and if his income is good, and if he is not having any other loan commitment, then you can give him a loan. Okay, then you can give him. If he's a salary person, you can give him a loan, because you can trust him. Every month, first he is getting the salary, his income is also very good, you can give him. That doesn't mean if a person is getting very good salary, and we have to give the loan to all the persons who earns more, right? So, and you need to check their commitments. If they have multiple loans, and if their EMI for the for all the loans EMI makes up his entire salary, then there is no point in giving the loan to him, right? So he teaches you all the patterns, whom to give loan, whom not to give loan, isn't it? Once you learn it from your father, it's nothing but the data, the historical data. Here the father is historical data. You learn the pattern from the historical data along with the input. With this combination, with combination of column, okay, and we determine whether customer is profitable customer or not. See, in this case, a person is owning a loan already, is already having a loan, and his income is okay, and years of credit is. You just think, for the 9 years he has a relationship with our bank, but still, right? This is a different pattern. He is not owning a house. Then he is not a profitable customer. So you need to, with the help of the input features, we are going to, label each customers, right? So you need to tell this algorithm. You need to train this algorithm with this historical data. This historical data consists of both input as well as labeled output features. This is mandatory in the case of supervised machine learning. Okay, the algorithm got trained, and now if I ask this, now this algorithm learned the patterns. Okay, if the customer income is less, and if he is already owning a loan, and if he has no house, don't give him the loan. Likewise, it learns all the patterns. Okay, and since this machine learning algorithm got learnt all the patterns, if you apply this algorithm on any new customer, it can make a prediction. For example, this customer is a new customer. He applied for a loan. Okay, he is a first time customer. He applied for the loan, and his years of credit is something like that, and then his income is 72,000, and he is owning a house. Loan balance is 2,000. He has no delinquent accounts related history, and nothing is there. Now your algorithm, based on the patterns which it learns from this historical data, can this algorithm approve the loan for this customer or not? All of you, please type it in the chat window. With this, I'm going to wrap up. I know, guys, it's already too late, and 7 p.m. Now you tell me whether this algorithm, see, in the case of decision tree, one beauty is the decision tree, what happens is, right, it automatically generates the rules. Okay, see, now the decision tree algorithm generated the rules like this. If delinquent account is more than 2 and maximum billing cycle date is more than 1, right, so then profitable customer, no. Okay, deny credit card application. If the delinquent account is 0 and income is more than 40,000 or years of credit is more than 3, then is a profitable customer. Based on the historical data, the patterns which was learned by the decision tree, right, it automatically generates the rules. Now you apply the rules and tell me whether this guy is eligible for loan or not. So it has to predict the label here, yes or no. Okay, so it has to predict the label here. So when we train the algorithm, we give the input as well as the output. If the input is so and so, this is the output. We already told him upfront. But if any new customer comes, we do not know his output, right? So my algorithm has to predict the output based on the patterns learned from the historical data. Now you tell me whether this algorithm is going to predict what, which yes or no, which label it is going to predict it here. You just use this rule also, right? Apply this rule here and you decide and tell me. All of you, please give me the answer here. This is the fundamental thing. Jiva, very good, right? Jivanandam, you gave me a correct answer. How about others? What is the predicted label here? How about others? I need all your contribution, please. This is a very basic thing. What is the predicted label here? Output. Predicted label output. What is the predicted label? See, your algorithm has to predict based on this pattern, right? So how about Mala and Mukilan? Mukilan is not there. He dropped out frequently. Palani. How about Palani? Palani, all of you, please concentrate here. Or if you think you are exhausted, you tell me, we will wrap up, okay? at least 1.5 hour, right? Sumati, you are correct. Jivanandam correct and Sumati correct. And Mala says yes. Predicted output, the predicted label output, yes. How about Palani? Palani, are you able to understand or not? Simple. If you concentrate here, you should be able to understand. So, okay. Okay, fine. So far, the majority of you have given the predicted label output as yes. Look here, Palani, are you there? If you apply this rule, what happens? Years of credit, right? Years of credit is more than 3. Yes, it is more than 10. And his income is more than 40K. Delinquent account is 0. Then he is a profitable customer, right? It will give you the output, yes. In the case of decision tree, it generates the role, okay. Likewise, there are a couple of, or the host of supervised machine learning algorithms are there. So what it does is, based on the patterns learned from this historical data, it can predict the label output, say yes or no. So in this case, based on the pattern it learned, it will say yes, and then as a manager you need to approve the loan to him. Let's say you are piled up with 0.2 million loan applications. Do you think practically you can go and check each and every customer's data or application? See, again, you cannot simply go by the income. You need to look at various factors. When you look at, see, in this case, for example sake, I put only 7 columns, okay. In the loan application form, you can go to Bank Bazaar, you can apply the loan there, right? In the loan application form, you see a lot of columns are there. At least 10 to 12 columns, 15 columns are there, right? You need to fill each and every column, and you need to look at the combination of various things. The person is owning, income is good, but he is not owning house, his loan commitment is more. In that case, we cannot do. Likewise, you need to scrutinize each and every combination of the columns, and then you decide. There could be a chance you might tend to make a mistake. Right? Number one is mistake. You can tend to make a mistake, and also it is time consuming one. If you don't approve the loan on time, even your potential customers may go and get a loan from your competitor's bank. You will lose the business. Number one is, it takes a lot of time, and again, human effort, right? So human, anything involves a human thing, right? It leads to error, some amount of error, right? There could be some kind of mistakes can happen. Like human make mistakes, even machine learning algorithms can also make mistakes. It is not that machine learning algorithm will not make any mistake. While making a prediction, even the machine learning algorithm can also make a mistake. That is where, as a data scientist, we are supposed to do some tuning everything. If I train the machine learning algorithm with the historical data, if it predicts accurately, then why a data scientist required, right? So not always the machine learning, or we can expect the machine learning algorithm to give the accurate predicted label output. It can make some kind of misclassification also. That is where, as a data scientist, we need to do tuning everything. Okay guys, it's already 7:10, and it seems most of you got exhausted. We'll continue the session tomorrow. By 5:15 we will start, okay, and then we will wrap up by 7 p.m. And tomorrow what I will do is, I will continue with some more the fundas, the overview of the machine learning and deep learning, and then we will jump into the supervised machine learning algorithm tomorrow, okay. Fine, okay, let me see if I can get access to AWS shortly. Most likely next weekend it will be okay, and we'll try to give a demo there also, side by side, if possible, okay. But at least we will start now. For the next 2 to 3 weeks, we will focus on the basic algorithms, okay, and then we will get into cloud and all, okay. Any questions so far? Alright, since you don't have any questions, I'm going to wrap up the session. We'll upload the video little later, and we will circle back tomorrow by 5:15 p.m. It is confirmed, okay.